Hello everyone, welcome you all at Lokesh Sir Unlimited Study Zone. We are here starting physics exact question paper of year 2025. Okay, having the code is here. It is given the code 55 oblique B. Okay, so let's start with the first question. Here it is our first question. Yes, which of the following statement about electric field E is incorrect? Important line, incorrect. Okay, you have to find the incorrect statement related to this electric field. All the options. The first A, the magnitude of the electric field due to the point charge is proportional to 1 upon r square, where r is the distance of the point from the charge. Second, the magnitude of the electric field is zero at all point in a region where the potential is zero. Third, electric field is a vector quantity. And fourth, the magnitude of electric field at a point measure the force experienced by a unit charge at that point. Tell me which one is the incorrect option. So student, here the correct answer is B. Why? First option, the magnitude of the electric field due to a point charge is proportional to 1 upon r square. Exactly correct, students, because the magnitude of E is given by the formula E is equals to 1 by 4 pi epsilon naught into q upon r square. Okay, so clearly here is E is proportional to 1 by r square. It is said to be E is inversely proportional to r square. So this statement is true. Second, the magnitude of electric field is zero at all the points where the potential is zero. Exactly. Where the potential is zero, magnitude of electric field is zero, because the formula E is equals to dV by dr. This is the formula for relation between electric field and uh, what potential. Okay, so E is equals to dV by dr. So important line here is when by the formula E is equals to dV by dr. So if V equals to 0, then differentiation of 0 will become equals to 0. Clear, students? Yes. So the magnitude of electric field is 0 whenever potential is 0. But remember, its converse is not true. Okay. When elect when potential is 0, then electric field is 0. But when electric field is 0, it is not necessary that potential is 0. Okay, write it. When potential is 0, then there is compulsory that electric field would be 0, but its converse is not true. Clear? Yes, right. When potential at a point is 0, when potential at a point V equals to 0, okay, then E is necessarily 0. E is necessarily 0. But second, when E is equals to 0, then V is 0, not required, not necessary. Clear? Not always. So there is possibility V may be 0 or V not equals to 0. Clear or not clear? There V may be 0 or V is not equal to 0. Both the cases are possible. Clear? Like example, see, in the case of equatorial position in a dipole, there is a minus q and here it is a plus q. Clear? So check this at the point of equator. At this point, what is potential? Here potential equals to 0. Clear? Potential equals to 0. Why potential equals to 0? Because if this point A and this point is B, then by the formula V is equals to 1 by 4 pi epsilon naught q upon r. Okay. So by applying this formula for both the cases, VA potential due to point A will become negative 1 upon 4 pi epsilon naught charges minus q by r. And for charge B situated at B, V is equals to 1 by 4 pi epsilon naught capital Q upon R. Clearly VA plus VB are equal and opposites, so they will give a result of 0. Clear or not clear? But when you're talking about electric field, so see here the electric field for a unit positive charge. To find the electric field, you have to place a unit positive charge. The direction here it is this. and here the direction of electric field is outward. Clear or not clear? Now the resultant of the two vector will be passing through this. Okay. Yes, so is here this is electric field. Clearly V is equals to 0, but E is not equal to 0. Got it? So done. So here the magnitude of electric field is 0 whenever the potential is 0. Okay, so potential, when potential is given 0, then it may be possible. It is sure, may be possible. When V equal to 0, then it is sure, then there will be equals to 0. But its converse is not true. Okay. Yes, one more thing you have to write. When V equals to constant, yes, V equals to constant. For constant potential field, electric field equals to 0 for a constant potential zone. Clear? Yes. When V equals to constant, that surface is called equipotential surface. Equipotential surface. Okay. So this surface is called equipotential surface. So for a equipotential surface, electric field is always 0 inside that surface. Clear? Like example, when there is a hollow sphere. Yes, here it is a hollow sphere. So in a hollow sphere, potential, all the charge given resides on the body of the conductor, hollow charge sphere, spherical conductor. So the potential V equals to 1 by 4 pi epsilon naught multiplied by Q by R. Clear? If Q is total charge. Clear, beta? And potential is throughout constant. Everywhere potential is constant. Now here E is equals to, by formula, dV by dr. So E is equals to dV by dr. So d by dr, this should be a small r, d by dr. And the value of potential is constant as it is equipotential surface. So it is constant. And the differentiation of constant becomes 0. So electric field here equal to 0. This means inside the conductor, there is electric field equal to 0. Clear? In a hollow conductor, electric field equal to 0. Clear or not clear? In a hollow conductor, this is hollow conductor, hollow conducting sphere. Sphere. Electric field equal to 0. Okay. Yes, here electric field will be maximum, E max. And I write all the formulas. So inside the center equals to 0. At the surface, electric field equals to 1 by 4 pi epsilon naught. Total charge given capital Q upon radius square. If the radius is capital R, it will be 1 by 4 pi epsilon naught into Q upon R square. And for outside point, if the radius, if the point is R distance, point P, then electric field at this point equals to 1 by 4 pi epsilon naught into capital Q upon small r square. Clear or not clear? Yes, so I can make here the variation of electric field with respect to the distance. So up to when you are inside the sphere, yes. So for r equals to capital R, this is equals to capital R. And inside the radius, electric field equal to 0. Got it? At the point of radius, electric field sudden rises and its value become the maximum value 1 by 4 pi epsilon naught Q by R square. So it may be written as KQ by R square. Clear or not clear? Then after then it is decaying with the rate of a small r square inversely proportional to R square. So this is the graph versus electric field intensity versus R, where R is the distance of the point from the center. Clear? R is this distance from the point of the point from the center. Clear, students? Now, the second option, so it is correct. It is what incorrect. Okay. So a magnitude of the electric field is 0 at all the point where the potential is 0. So it is uh, not necessarily true. So this is the answer. Electric field is a vector quantity. Obviously, beta, electric field is a vector quantity because electric field is equals to force per unit test charge. Write the formula. E is equals to F by Q naught. As F is vector, that's why E should also vector. The magnitude of electric field at a point is measured by force experienced by a unit charge. Definitely. So this formula reflect the same definition. E is equals to F upon Q naught. Clear? Yes, done. Okay, student. Now discussing the second question. A battery of EMF 6 volt and internal resistance of 0.40 ohm is connected to external resistance of 11.6 ohm. The power dissipated in the external resistance. Okay, we have to find the amount of dissipated power. So first make the circuit diagram here. What type of circuit is here? So a battery is there. Battery having a EMF. This is called EMF E. And EMF of the battery is given here 6.0 volt equals to 6 volt. And a very small internal resistance R internal, that is denoted by small r, working there 0.40 ohm. So it is equals to 0.4 ohm. And this circuit is connected with the external load resistance, commonly known as capital R. And the value of this load resistance equals to 11.6 ohm. Okay. And you need to find the amount of power dissipation across what? Power dissipated in external resistance. Yes. Okay. So you have to find the power across this power dissipated across this resistance. Find P. What is P? Okay, let us see the solution of this one question. So we have a circuit like this. So first we have to find the current. Okay, because the question is asked about the power dissipated across R. About only the power is asked consumed by only this resistance. So we have to find, either we have two chances, two cases are there. Either you find the voltage drop across this resistance, that is difficult one, or you can go with the current flowing through this resistance. So we have the value of I. First, we have to find the value of I. For that, we have to find the total resistance as its series circuit. So the resistance will be added up and give a total resistance of 12 ohm. By the Ohm's law, V equals to IR. Here the EMF is working. So E equals to I into R net equals to 6 volt multiplied by I into 12 will give you a current of 0.5 ampere. Fine. Now you can apply the formula P equals to I square R. For a series circuit, this formula is usable. P equals to I square R. So I equals to 1 upon 2 whole square into 11.6 is the net resistance of this one, not net, sorry, only of R. Okay. If you will take the total resistance, this one 12 ohm, then you will get the total power dissipated in the circuit in both the resistances. Clear? But you have to find only the power dissipated across this resistance. So you have to take only this one's resistance, that is 11.6, and you will get an answer 11.6 by 4, that is equals to 2.9 watt. Clear? Yes. Yes, the power dissipated by the 0.4 ohm will be a different one. You can also find this power with the same result, P equal to I square R. That time current will be same, 1 upon 2 square, but resistance will be 0.4 ohm. Okay? Yes. Now we have uh, three formulas for the power dissipated. Electric power, P is equals to V into I. Okay? And P equals to V square upon R, and P equal to I square into R. Okay? So according to your convenient, you can apply either of the formula, any of the formula. Then students, okay. Next question, student. The acceleration of the particle of mass m and charge q moving with a uniform speed v at a right angle to the magnetic field is given by, which one will give you the correct acceleration? Okay, so what is happening here? Take a slight idea of this. Like this is a magnetic field, a uniform magnetic field is here. Okay, so B is the magnetic field, and an electron particle, a particle of mass m. Yes, so this is the particle of mass m, some mass m particle. It enters perpendicular to the field, magnetic field. Now tell me, okay, so velocity is at right angle as it is entering like this. So velocity is the right angle to the field, magnetic field is going like this. So you have to find the acceleration. Okay, fine. Okay, let us see, student, the solution of this question. So particle of mass m is there, and is this particle is entering perpendicular direction to the field B. So here is the angle between B and V is equals to theta becomes 90 degree. Okay. So as we have learned this condition that when B is perpendicular to V, so the particle will move in circular path. So the circular path, for the circular path, the necessary force provided by the magnetic force will be becomes as a centripetal force, okay, or you can say the circular force, centripetal force required to rotate in a circular path is provided by the magnetic force. So Fc, so the actual value of Fc is equals to mv square upon r, but we have to find the acceleration. So we have to write here the value of force equal to mass into acceleration. So we have expressed this force in the form of mass and acceleration by Newton's law, F equals to ma. Clear, students? Now, F equal to ma becomes magnetic force, that is equal to qvb sine theta. Now, the angle of theta is here 90 degree. Place the value 90. Sine 90 becomes 1. So, it is equals to qvb equals to ma. Now, acceleration equal to qvb by m. Clear? So, check the correct answer, qvb by m. Does there any option like this? Yes, it is B. So, qbv by m is the acceleration. Okay, guys. Now, if they ask you about radius, then what you have to do? Then that time magnetic force is equals to centripetal force, means magnetic force will provide the necessary centripetal force. Now, this is equals to qvb sine 90 is equals to mv square by r. V 1 and 1 v cancel. So, radius of the path is equals to m q mv by qb, because 1 mv will be left here at the numerator and qb will transpose here. So it will give you mv by qb. Clear or not? This is equals to what radius? Clear? Now, if I talking the time period, so time is equals to what? As we know, is speed equal to distance upon time. So time is equal to distance upon speed. Is distance upon speed. So for a complete one revolution, distance become 2 pi r. So distance equals to 2 pi r. R is the radius. And we should have to take the small r as we have derived here with the name of a small r. Upon speed, speed equals to v, right? So place the value of r here. So t is equals to 2 pi upon v is here. And the value of r equals to mv by qv. So it is equals to mv by qv. Now v and v get cancelled out and t is equals to 2 pi upon qb. Clear, students? So t is equals to 2 pi upon qb, 2 pi m, sorry, 2 pi m upon qb. And talking about frequency, frequency equals to 1 upon time period. So this is equals to qb upon 2 pi m. Completed. All things are completed. Clear? Okay, moving to the next question. Question number 4 is related to the chapter electromagnetic induction. Current of 5.0 ampere in one coil is reduced to 0 in 10 millisecond, inducing a EMF of 9.0 volt in the neighboring coil, then the mutual inductance of the two coils. So you have to find here the mutual inductance of the two coil. Let's find. Let us see the concepts, students, related to this question. So by the concept of mutual induction, we know we have the formula E is equals to m di by dt, right? So the current is changing from 5 ampere to 0, means the change of current is from 5 ampere to 0. Clear? In 10 millisecond. So time is given here, delta t is equals to 10 millisecond, that is equals to 10 into 10 to the power minus 3 second, converted in the SI unit. Okay, and EMF is produced 9 volt. So replace all the values. EMF is here 9 volt, and the formula of mutual induction E is equals to m di by dt. Okay, so m change in current from 5 to 0. So this is equals to 5 and here 10 to the power minus 2. On solving, you will get m equals to 18 into 10 to the power minus 3 Henry. That can be written as 18 millihenry. Clear, students? Okay. Now, next question. Fifth question from the chapter AC. Which of the following statement of transformer is not correct? Okay, we have to find the incorrect statement. For ideal transformer, P output power is equal to the input power. For ideal transformer, they are saying P out is equals to P in. Second, a transformer can work for both alternating and for AC and DC, for both alternating and direct voltage. Okay, alternating and direct voltage. Second, third, Third, for a step-up transformer, the voltage across the secondary coil is higher, but the current is lower. For an ideal transformer, the magnetic flux link with the secondary coil is equal to link with the primary coil. So tell me which is the correct answer. Okay, let us talk one by one. For ideal transformer, the output power is equal to input power. Correct it is. This is the concept for the transformer. Output power is equals to input power. Yes. So talking on the same concept, this is question number fifth. Okay. So principle of transformer for an ideal transformer, P out is equals to P in and power is equals to V into I. So this can be written as V secondary into I secondary is equals to V primary into I primary. Okay, P equals to VI. Now V secondary upon V primary, this is equals to I primary upon I secondary. Okay, this is called transformer ratio and it is equals to N secondary upon N primary. This is called transformer ratio. Clear, students? Transformer ratio. Now, check here the voltage is inversely proportional to the current. V is inversely proportional to the current. Okay. So as voltage increases in the same winding, the current will be decreases. Okay. So like if voltage of the primary coil increases, then current from flowing from the primary coil will be decreases. And if voltage from the primary coil is decreases, then current from the primary coil will be increases. So first, it is absolutely correct. For ideal transformer, input power is equals to output power, but we have to find the incorrect one. So reading the second question, transformer can work both alternating and direct voltage. No, false it is. A transformer is work only on the AC. The transformer can only work on the AC. So this statement becomes incorrect. Yeah, check more options. For a step-up transformer, the voltage across the secondary coil is higher, but the voltage in it is lower. Yes. So in a step-up transformer, the step-up transformer make the output voltage high. So V secondary is greater than V primary. V secondary is the output voltage. So if the voltage will become high, the current will become low, definitely, because V is inversely proportional to current. Okay. So if voltage become larger, currentage become lower. Okay. So it is correct. Secondary voltage is high and the current will be lower. For an ideal transformer, the magnetic flux link with the secondary is equal to the primary. Bilkul. Obviously, it is correct. As the flux will be same, so the same EMF will be created here. Okay, then this becomes ideal transformer. Okay. For ideal transformer, there is no flux leakage. Total flux that link with the primary coil also link with the secondary coil. Means flux will be same phi primary equals to phi secondary. So answer here is option number B because B is incorrect. Transformer can work only with the alternating supply. Why? Because XL is equals to XL is equals to omega L. What is XL? XL is the reactance of the coil. Reactance of the coil, right? Of the coil. And XL equal to omega L. And XL, omega, the value of omega L equals to omega equals to 2 pi F. 2 pi F into L. If you apply DC, for a DC voltage, frequency equals to 0. For a DC supply, frequency equals to 0. So if you placing here the value frequency equal to 0, so XL become 2 pi and frequency 0 into L. So XL, the inductive reactance equals to 0. So this will provide ideal path for DC. Clear? No induction will be there. No induction will be there. This will provide the ideal path for the DC. Clear or not clear? So it is applicable only for AC. Yes. So transformer is used only with the AC supply, not for DC supply. Done. Okay, student. Moving to the next question. Which of the following will not increase the input voltage in a generator? Tell me which of the method will not increase, not change the output voltage in a generator. Okay. Rotating of the coil rapidly, changing of the material of the coil, increasing the area of the coil, and increasing the magnetic field through the coil. So which of the method is incorrect for increase of output voltage? Tell. See student, there is the talking about voltage. So we know the formula induced voltage by the induction method E is equals to d phi by dt, d by dt of phi. And you know the value of formula phi is equals to NBA. Okay. Phi is equals to B dot A. So NBA cos theta. Yes. Yes. What is phi? Phi is equals to NB dot A. So this is equals to phi is equals to NBA cos theta. So E, the value of E by the Faraday's Lenz's law, E is equals to d phi by dt, right? E is equals to, and minus sign will be there. That opposing EMF developed, that is called back EMF. So E is equals to minus of d by dt, and the value of phi here, it is equals to NBA cos theta. Now, what things can increase or decrease the voltage? First, E is proportional to N. Yes, if you increase N, then the value of the EMF will be changes. Clear or not clear? E is proportional to N. Second, E is proportional to magnetic field. If you increase or decrease the magnetic field, then there is a change of magnetic field. EMF will be increases. Clear or not clear? So on changing the magnetic field, uh, dB by dt, you can write E is proportional to dB by dt. So EMF can be raised, can be developed by changing the magnetic field. Third, E is proportional to dA by dt. In motional EMF, we have changed the area of, yes, this section. So EMF can also be created by changing the area, right? And by changing the angle of the coil, EMF can also be developed. So E is directly proportional to d by dt of cos theta. Okay. So all the options are correct. Like rotating the coil rapidly. When you rotate the coil, then there will be a d theta by dt. When you changing the material of the coil, yes, this is the correct answer. No, not increase. There is no dependence on the change material. There is no any dependence of the change of flux with the material. Yes or no? So if you change the material, there will be no impact. Increasing the area of coil, yes. Whenever you change the area of coil, it is also depends. EMF also depends on the change of area. Increasing the magnetic field, yes, it is also depends dB by dt. Clear? So correct answer would be B. Next question, student. In free space, which of the following quantities will always larger for X-rays than for a radio waves? Okay. So we have to find the quantity which is larger for a X-ray than compared to the radio wave. Tell me which quantity will be larger. So correct answer is student here frequency. Okay, so you will be given 1 out of 1 frequency because X-ray is more penetrating wave than compared to the radio wave, and the radiation frequency energy of the radiation becomes h nu. So when nu becomes high, its energy also become high. That's why X-ray is a dangerous type of radiation that is used also for taking the image of our bones. X-rays. Okay, speed for every electromagnetic wave, speed will be constant. C, okay, speed of light. Frequency, yes, frequency of the X-rays is greater than, okay, than the radio waves. Amplitude of all the EMF, electromagnetic wave are nearly same, and wavelength is shorter. Yes, lambda for X-ray is lesser than lambda for radio because frequency is inversely proportional to wavelength by the formula C equals to nu lambda. Okay, C is equals to nu lambda. So lambda is equals to C upon nu. So when frequency increases, the wavelength will be decreases. Okay, so here the frequency of X-ray is greater than the frequency of radio waves. Okay, so lambda of X-ray will be lesser than the lambda of radio waves. Clear? Yes. So correct answer is here B, frequency. Done. Next question is student, the depth of a swimming pool, refractive index of the water equal to 4 by 3 is given, is 1 meter. Okay, so depth is given here. The swimming pool is 1 meter. This is the totally depth of the swimming pool. Now, if one looks straight vertically down, if one looks straight vertically down, then the depth of the pool will be appeared as. So tell me what will be the depth of the pool when it is looked at vertically. What will be the depth of the pool? Okay, so let's solve this. So formula for the apparent depth, h dash is equals to h by mu. So here h is equals to 1 meter, okay, and 1 here 4 by 3. So 3 will get here and 4 will be here. Clear or no? So 1 upon 4 becomes 0.25 and 0.25 into 3, that is equals to 0.75 meter. So correct answer equals to 0.75 meter will be the depth of the swimming pool. Clear? Okay, student. This question is related with the dual nature theory and radiation chapter. Okay. A beam of red light and a beam of blue light having equal intensity. It implies that red light beam has higher number of photon that in the blue light beam. Blue light beam having higher number of photon that in red light beam, and both beams contain the same number of photon, and the momentum of the photon for the red light beam is more than that of photon for blue light beam. Tell the answer. Okay, students. So first, we're talking about intensity. So what is intensity? The formula for intensity is equals to intensity of a radiation means the number of radiations means the amount of energy impacted on given area per unit time. Okay, this is the relation for a given intensity. Okay, energy per unit area per unit time. Now, energy equals to h nu. Clear? Area and time. So nu h is constant here. Area is also not given in letter, so we have to take in as constant. Time is also same. So nu equals to c upon lambda. So intensity equals to c by lambda. Clear or not clear? Intensity equals to is proportional to c by lambda. C is also constant, so mainly intensity is proportional to 1 upon lambda. Clear or not clear? Okay. So you can say I is proportional to lambda. So I into lambda becomes constant. I into lambda becomes constant. Clear or not? Okay. Means I1 lambda 1 equals to I2 lambda 2. I1 lambda 1 equals to I2 lambda 2. Yes. So here first wave is what? Blue. Red light is there and blue light is there. So two things are there, about two things, lambda red and lambda blue. Check lambda red and lambda blue. Red color having highest wavelength, right? So red color having highest wavelength and blue color having lowest wavelength. Clear? So to make the value of constant I1 lambda 1 equals to I2 lambda 2. So let us, this is I red lambda red equals to I blue lambda blue. Clear or not? I red lambda red equals to I blue lambda blue. So if lambda red is greater, to make a constant value, intensity of red color will be less. Okay. And wait. Make it more informative like this. I read I into lambda equals to constant. So I into lambda equals to constant. I1 upon I2. Make a relationship. I1 upon I2 is equals to lambda 2 upon lambda 1. Clear, students? I1 upon I2 is equals to lambda 2 upon lambda 1. So I read upon I blue equals to lambda 2. 2 means blue upon lambda red. Clear or not clear? So as lambda red is greater than lambda blue, as lambda red is greater than lambda blue, this means lambda red upon lambda blue will be greater than 1 and lambda blue upon lambda red will be less than 1. Clear? So here the value of intensity of red is less than intensity of blue, means intensity of red color will be less than intensity of blue color, as lambda b upon lambda are less than 1, means red color having less intensity and blue color having more intensity, means the number of photon in blue color are more and the number of red color will be less. Okay, so the correct answer, blue light having higher number of photons, yes, then that of red beam light. Clear? So answer will be B here. Done. Student, some incorrect explanation is given, so I am going to explain it once again. Remember, intensity is equals to energy per unit area per unit time. Okay, this is the relation for energy. Now question is, a beam of red light and beam of blue light have equal intensity. So intensity is given here, that intensities are equal. Okay, we don't have a right to change the intensity, and in the last previous explanation I have changed the intensity. So they having equal intensity. Okay, so make this one E equals, intensities are equal, means I1 equals to I2. Clear or not clear? For both the cases, I1 equals to I2. This means I red equals to I blue. Clear? So when both the quantities are equal, this means you can write E red upon area red and time red, and here E blue for area blue and time blue. So both are cancel. It means you have to write E red equals to E blue. Both the energy will be same. Clear or not clear? Now E energy equals to H nu. Energy equals to H nu. So H nu equal to Hc by lambda. Okay. E energy should be equal. So E equals to Hc by lambda. Clear? Now check here. E is inversely proportional to lambda. This means the radiation having higher wavelength having less energy. Yes or no? The radiation having higher wavelength having less energy. So here the red color having higher wavelength. Yes, red color having what? Higher wavelength. Clear or not? So whenever red color having higher wavelength, it means the energy of red color will be low. Yes or no? Yes. In comparison to the blue color having less wavelength, so the energy of the blue color radiation will be high. Clear or not clear? Yes. So blue color will have higher energy and red color will have low energy. But to make them equal, you have another choice, that you have to increase the number of photons for the red color. So red photons, no, no, no. The intensities are equal, but intensities may be equal in the terms of wavelength. The questions are in the terms of wavelength. You have to equalize the intensity, okay, in the terms of wavelength and in the terms of number of photon. Actually, intensity means what? Intensity equals to energy per unit area per unit time. Okay, energy per unit area per unit time. Yes or no? So, so what I say, lambda r is greater, so energy of the radiation will be low. Okay, to make it sufficiently high, you have to increase the number of photons for red. Okay, so red numbers having more photon comparison to blue numbers having less photons. Okay, and for a given area, they will produce you same intensity. Clear or not clear? So here the correct answer will be red beam of light having higher number of photons than that having the blue light of beam. Clear or not clear? Yes. Like there is a unit area, and this is the length of unit area. Consider this one is the unit area. Okay. Yes, this is the unit area. Now they having same intensity. Yes, same intensity means same energy per unit area, same energy on falling on this area. Clear or not clear? So it is also giving you same intensity. Whether when whatever the number of photons are large, but they will give you the same intensity. Question is like this. Okay, so correct answer, the red beam of light having higher number of photon than that in blue beam of light. Clear? So answer in the place of B, it should be A. Let us check the answer. Mm, answer yes, ninth is A. Okay, clear? So red beam of light having higher number of photon than in blue beam of light. Clear, students? Okay, make it right. Next question is, if 1 milligram of mass is converted into the energy, then the energy released will be. Yes, tell the answer. Okay, student. Next question is question number 9. Very simple. Here the mass is given here 1.0 milligram or 1 kilogram mass is converted. So by the formula of delta E is equals to delta M into C square. Yes, energy, amount of energy. Okay, so delta E here, E is equals to mass is given here 1 milligram. So 1 into 10 to the power minus 3. And the value of C equals to 3 into 10 to the power 8 meter per second whole square. So 3 square becomes 9. And here 8 square 16. 16 minus 3. Okay, 8 into 2. 8 into 2 becomes 16. 10 to the power 16 minus 3. How much it will be? 13. Okay, student. So it is first has to be converted in kilogram. That's why the mistake is there. So first milligram, 1 milligram here it is equals to gram. Okay. Now, so this is equals to 9 into 10 to the power 16. Now 1 gram equals to how much kilogram? 10 to the power minus 3 kilogram. Because 1 gram equals to 1 upon 1000 kilogram. Okay, so a more 1 10 to the power minus 3 will be there. So 10 to the power minus 3 into 10 power minus 3. Now it is in kilogram and here it is meter per second. So we can convert it into the joule. Okay, so 10 ki power minus 3, 10 power minus 3 become 10 ki power minus 6 and will cancel 10 power 16. Your answer finally will be 9 into 10 to the power 10 joule. So your answer will be C. Clear? Next question, students. Which of the following impurity atom, when doped in silicon, will produce a N-type semiconductor? So you know N-type. N-type means pentavalent impurity, means 15th group. 15th group is no nitrogen, phosphorus, arsenic, antimony, and bismuth. So tell me which impurity you can add. Nitrogen is not there. Phosphorus is not there. Arsenic, mm, nitrogen, phosphorus, arsenic. Yes, arsenic is there in first option. So you have to add N-type impurity, and N-type means nitrogen family impurity. So nitrogen, phosphorus, arsenic, antimony, bismuth. So correct answer is arsenic. Okay.